Hey guys, I'm Jay. Today is my LeetCode review one-take vlog on 637th problem. Average of levels in binary tree. We are given the root of a binary tree. We'll return the average values of the nodes on each level in the form of an array. Answers within 10 to negative 5 of the actual answer will be accepted. Let's see example 1 here to understand this problem easily. We got an input binary tree here, and the average value of nodes on level 0 is 3, on level 1 is 14.5, and on level 2 is 11. So we'll return these values. And then let's get started with our intuition and main idea to solve the problem. And there are two common approaches. First, we'll use the level order traversal or breadth first search. We'll traverse each level of the binary tree, and then we'll use a queue to process nodes level by level and get the answer. Second, we can use a depth first search to keep track of the sum and count of the nodes at each level. And let's implement those approaches and analyze their time and space complexities. First, let's implement this problem with breadth first search. First is breadth first search. And first of all, we'll create an array list to store the average of each level. So the code is list of double. Let's call it list equals new array list. And then we'll handle an edge case. If the tree is empty, we just return an empty list. If root equals null, we just return the empty list. And then we'll create a queue to do the breadth first search traversal. And the code is queue of tree node. Let's call it queue, and we will assign a new linked list instance to the queue variable. New linked list instance. And then we'll start the breadth first search by adding the root node into the queue. So the code is queue.offer of the root node. And then we'll create a while loop to do the BFS traversal. And the condition is not symbol with queue.is empty. And for each iteration, we'll determine the number of nodes first. So the code is level size, integer level size equals queue.size. And then we'll initialize a level sum variable to help us store the sum of current level. Let's call it double level sum started at 0. Then we'll process each node in this level. We'll create a for loop. Let's say integer I starting at 0 and I should be less than level size. We'll increment I after each iteration. And inside the for loop for each node, we'll add its value into the cumulative level sum variable. First, we need to get a tree node. Tree node equals queue.call. And then we want to get the value of the node, and we'll add it into the level sum. Level sum plus equals tree node dot value. And then we also have to enqueue the nodes left subtree and the right subtree for the next level. So code is if current node dot left is not equal to null, which means this node has not null left subtree. If tree node dot left is not equal to null, we'll add a subtree left subtree into the queue. The code is queue dot offer of tree node dot left, and is very similar for the right subtree. If tree node dot right is not equal to null, we'll add a right subtree into the queue. Tree node dot right. And out of the for loop, which means we have processed all the nodes in this level. Then we need to calculate the average number by dividing level sum by level size, and we'll add this value into the averages list. Of the for loop, list.add with level sum divided by level size. And out of the while loop, we just return the list of averages for each level. We just return list. Let's submit code and check for its correctness. And then let's analyze our time and space complexity. Yes, our code got accepted. So the time complexity, it is big O of n, and n stands for the number of nodes of the binary tree, because we visit each node from the binary tree only one time. And the space complexity, it is big O of m. M is the maximum number of nodes at any level in the binary tree. And there are two special cases. If the tree is a skewed tree, the m could be big O of 1. The m could be 1. But if the tree is a balanced tree, the m could be half of n. So it depends on different conditions. And then let's get into the second approach called depth first search. And the main idea is we'll create two lists to help us solve the problem: a sum list and a count list. And then let's get started with our code. First, let's create a double list called sums. We need to keep track of the cumulative sum and count of nodes at each level. And we assigned a new empty array list into the sum list. New array list. And we need to create another counts list. And then we'll start the depth first search traversal. But we need to create a new helper method called DFS, which means the depth first search, because we have to do the recursion. Depth first search, and this method will take 4 variables. First is the current node, and then is the level, and the sum and count list. So for the first recursion, we'll input the root node and current level, which is 0, and the sums list and count list. And after the recursion, and then we'll create an averages list to store the average from each level. List of double. Let's call it, just call it list. we'll create an array list and assign it into the list variable. And then we'll do a for loop to calculate the average number for each level. The code is for integer I starting at 0. I should be less than sums.size, and we'll increment I after each iteration. And for each iteration, we'll add the results into the average list. The code is list.add with the result of sums.get of I divided by counts.get of I, which is the result, the average of each level. And finally, we just return the average list. And then we need to declare and implement the DFS help method. Private void and the name of the method. And this method needs 4 parameters. First is the tree node. Is the tree node for the current recursion. And second is the level. And the third is the sum list of double, as called sums. And the final parameter is the count list, counts. And then inside the DFS method body, first we need to do a bad case check. If node equals null, we just return. And then for each node, we have to check if we are visiting this level for the first time. If so, we'll initialize new entries in the sums and counts list. So the code is if level equals sums.size, which means it's our first time to visit this level. If so, we'll add new entries into the sums list and counts list we have to do a type transformation with node.value. And then we also add it into the counts list. Counts.add with 1, which means we got a new node in this level. And in another situation, if we already visited nodes at this level, we don't need to create any new entries for the sums and counts list. We just update the cumulative sum and count for this level. So the code is sums.set with the current level and the new sum number, which is sums get the level and plus node.value. And we also have to update the counts list with counts.set with the level and counts.get of the current level, and we just plus 1. And finally, we'll recursively call the DFS on the left subtree and the right subtree. And we need to pass level +1 to indicate that we are moving down to the next level. So the code is DFS recursion with 4 new parameters, which is node.left, which is the left subtree, and new level +1, and sums and counts list. And we have to do the similar process for the right subtree. And that's all the code for the second approach, depth first search. Oops, we had to integer cannot be converted into double. So at height we can counts. Counts could also be list of integer. Never mind. Yes, our code got accepted. And then let's analyze the time and space complexity. So the time complexity, it is big O of n, as we visit each node only one time in the binary tree. And the space complexity, it is big O of h, and h is the height of the binary tree due to the recursive call stack. And there are two cases. If the tree is a balanced tree, h could be log of n. But if the tree is a skewed tree, h could be just n. And this is the end of my LeetCode review one-take vlog on this problem. And I highly recommend you guys to visit my online GitHub page here, which contains all the problem description, intuition and main idea, and Java code with very detailed annotations, and final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the codes and nodes to build this online GitHub page. And thank you guys for watching. I'll put those two links on my YouTube description below. See you next time. Bye bye.